That's correct?
Sure.
Okay, cool. We'll rock and roll on that. OpenCog Project. Perfect. How's it going, guys? This is Dan Faggella here at the Sentient Potential blog. I'm lucky enough to be joined today by Mr. Ben Goertzel, who is a touted AI expert, in addition to the founder of the OpenCog project. Ben, how's it going, brother?
Pretty good. Pretty good.
Cool, man. Yeah, I know I just got to catch up with you at the 2045 event out in New York. And as I mentioned, a lot of the people we bring on board, one of the first things I always like to talk about is kind of how you got involved and invested in artificial intelligence, and particularly now, not just kind of the applications thereof, but the OpenCog project, transhumanism, and a lot of the things you're involved in now. I know you started in AI pretty early on, right?
Well, I've been interested in AI and other science fictional technologies since I was a child in the early 1970s,
Okay.
really. And I went to college at age 15 in 1982. Already that I was pretty hard about how thinking machines that would think in the same way people and better. But at that time, I was also interested in a host of other whack technology projects, including life extension for humans, building spaceships to travel to other stars, and how would you make time machines using the laws of physics and all sorts of
That's cool.
all sorts of out there things. In my mid to late 20s, I decided if I was going to accomplish anything real, I would have to focus a bit more. And I began gravitating more and more toward AI. By this point, I was a mathematics professor
Yep.
in university. One of the things that appealed to me about AI was the idea that you didn't need any expensive or complicated hardware to do it. It seemed that you could do it just by programming. Just figure out the right thing to type on your computer, and the computer could think. And that's an amazing idea. I mean, of course, making spaceships is awesome, but you need huge, nuclear reactors or something to power it. And
Yeah,
you can
yeah.
make a time machine by spinning a football-shaped star around. But again, that there are significant engineering difficulties there,
Yeah,
right?
especially for one guy. I mean, it's
Yeah, and even for the biology of life extension, which is something I'm still working on in spare time, doing experiments on people. I mean, it's either dangerous or very slow and painstaking. And
yeah,
there's all sorts of legal restrictions. And
yep.
plus, it takes a long time. Let's say I have a pill that will make people live 200 years. How do you test it?
Well, you gotta
200 years? Otherwise,
get the stopwatch out.
you're looking at biomarkers of aging or testing with other organisms.
Yeah,
I mean, AI, in a certain way, if AI can be achieved on plain old computers, in a certain way, that's simpler logistically. It all comes down to knowing what to do, and that at first I wasn't sure that I knew what to do, and after doing more and more research into cognitive science, neuroscience, computer science, philosophy of mind in various areas, I originated what I felt was a workable design for a thinking machine, which is quite complicated, but seemed, in principle, to be doable anyway. And I mean, the point I'm at now is I feel I have a design that could work. We are a fraction of the way through implementing it with the OpenCog project. We certainly would need a lot more money or a lot broader base of volunteer effort
yeah,
to get there to a human level thinking machine, but I think it's important to be making a start and actually doing work toward the goal anyway, instead of just talking about it.
big time. And I know you had mentioned obviously working in AI potentially would take less resources than spinning a football-shaped star, for example. But at the same time, the OpenCog project obviously does require a good amount of work, resources, etc. I know you're big on kind of collaborating, and you guys have a lot of volunteers. Go in, I guess, into a little bit of detail for the people watching as to sort of where the OpenCog project is now, what your guys' real mission is, and yeah, I guess what your progress has been up until now as well.
The OpenCog project has two aspects, really. One aspect is that we're just building a toolkit of useful AI tools, which can then be deployed within a variety of vertical market-specific applications. So, we've used OpenCog's language processing tools in some commercial products. For example, on the back end of a website for language learning, we've used OpenCog's machine learning tool, Moses, to analyze genetics data, to analyze music listening data and marketing data. And that's maybe not the sexiest aspect of OpenCog, but it's been helpful to me because I've been earning a living for a while doing AI consulting projects for various companies and government agencies, and often using OpenCog software components as tools.
Yep.
But the other aspect of OpenCog, which is more directly exciting for transhumanists, is our long-term goal is to use OpenCog to make a thinking machine. The grand aspiration is pretty big. I mean, we want it to be the next step beyond human beings. The short-term goal, or perhaps I should say the medium-term goal, is to create a robot toddler, say an AI with the rough intelligence of a 3-year-old child.
Yep.
And I think if you can get there, then you can get to the end game. I mean, I think a 3-year-old child has the common sense understanding that an adult human does, basically. And from the point of the 3-year-old onward, there's certainly more maturation of the mind that has to go on, and a lot more learning.
Yep.
Basic cognitive mechanisms are already there. And so that is our proximal goal with OpenCog, and we have a bunch more work, of course, to get to that point. Right now, we're playing around with the integration of AI with video game characters as a sort of simple prototype for controlling an autonomous, mobile, exploring, learning agent with OpenCog. And we're just getting started with connecting OpenCog to robots. We've begun a collaboration with David Hansen of Hansen Robotics.
Yep.
And actually, I'm going to bring a Hansen. I'm in the U.S. right now visiting family and for the Global 2045 conference. When I head back to Hong Kong, I'm going to bring a Hansen robot in a suitcase for the lab. So we're literally just getting started with the Hansen Robotics collaboration.
Smuggling robots on airplanes, gotta love it.
I'm excited about that too.
Yeah. And I guess maybe in layman's-ish terms, it sounds to me as though the creation of even kind of the toddler equivalent mental state or capacities is obviously a massive leap. You guys have been cracking away at it for quite some time. Is it possible to kind of explain what you feel like you need to do in order to move forward, or what elements you guys need to work on in order to kind of close that gap, or what your trajectory is now?
Sure. So we are moving forward. I mean, we have a team of 6 people in Hong Kong working on this, and we just have started a new team in Addis Ababa, Ethiopia, with a handful of people. And then there's scattered developers in other parts of the world, in the U.S., in Europe. 2 guys in Isfahan, in Iran, actually.
Cool.
So I think now we have a lot of interesting learning and reasoning components within the OpenCog architecture, and they all work together on the same knowledge base, which is called the atom space, which is the long-term and short-term memory of OpenCog. But not enough work has been done to get all these parts of the system to work together in a synergetic way for the goal of combining an agent. So the next challenge we have, really, during the next year and a half, is to make OpenCog's various components work effectively as an integrated system for controlling an agent. So right now, the video game character is controlled only by a couple different OpenCog components. But the other components are there in the code base and have been used for other projects. So we need to get them all working together to make the agent smarter and smarter. And that, in a way, it's challenging socially, because it means the programmers who wrote the different components have got to understand what each other did. Right?
Yeah.
So we're sort of in a system integration phase, not so much at the code level, but at the fine-tuning of the algorithms level, where each algorithm's got to be fine-tuned to work well with the other ones. And once we get done with that, then of course we may see that some of the algorithms need some improvement to work well in the context of the overall system. I mean, we have a high-level design for the OpenCog system, which is, close to 1,000 pages, but still, that only scratches the surface. There's more and more and more details.
Yeah.
Building a brain is hard. Look at the textbook of neuroscience is this thick. And again, that's only the abstract. You got to dig into the research literature, see what's really going on. Then OpenCog is not as complicated as a human brain, but even if it's 1/10 as complicated as a human brain, there's still a hell of a lot going on there.
Yeah, it's going to be a lot of code, so to speak. So okay, cool, kind of a system integration. Yeah, I imagine different people are writing different segments. That does add an entirely different element of kind of complication in there.
Yeah, and some segments are written by people who have moved on to and are not with the project anymore, and you got they did. I mean, it is a large-scale software engineering project as well as a research project, and having those two aspects pursued in parallel on the same code base has a variety of challenges associated with it. I mean, think about something like Microsoft Word. I mean, Microsoft has 100 people or something working on that constantly, year after year after year. Wow. But that's a tremendously simpler thing than building a thinking machine. So
yeah, so I guess getting the more people, the better, and I suppose the better the collaboration and more orchestrated.
But you need the right people. You need people who are good programmers and understand AI. And I don't think you don't want 500 people on a project like this. It would just be chaos and then confusion. But the point is, it's a large project, and one of the issues in the AI field is most work is done in universities by graduate students. So you have the idea that 1, 2, or 3 PhD students working with a professor is going to be able to make profound progress on the AI problem. But I mean, wait a minute, then why does it take 100 people to build and update Microsoft Word, right?
Yeah.
So, of course, a grad student or a small team thereof could make a conceptual breakthrough. If they could have an interesting insight that will move things forward. But to actually build an AI,
bigger deal,
a large-scale engineering problem, along with a collection of interlocking deep research problems.
And I think maybe the 100 people thing also ties into the whole profit element. Obviously, you guys are leveraging your technologies now in different markets, but Microsoft is, they're selling Word however many gajillion times over, so they can afford to have 100 people on it. Maybe that's why a lot of people think Google's gonna come through with a lot of breakthroughs, because they're able to leverage that technology in a profitable business sense, and they've got Kurzweil and all that. Do you kind of have an understanding of sort of the direction they're going and how many people they have working together? Or are they in kind of a different domain of AI? Oh, hold up. You broke up a little bit there, Ben. Give me a second here.
Then you're more likely to solve the problem that you're working on rather than something else, right? So that's right.
Oh, hold up. I think you just it just got a little bit sketchy in between there. Can you still hear me all right?
Can you hear me okay now?
Yeah, I can hear you decent now. Yep.
Okay.
I think it's when the camera moves around a lot. Skype gets all discombobulated. Silly old Skype. Anyway. Okay.
Uh,
Yep, a little bit. Hold on. I think it's got the camera's trying to settle itself a little bit. Let's see. Where are we? All right. Should be working just fine now. Are you still able to hear me okay, Ben?
yeah, I hear you fine.
Okay, great. I can hear you fine now too. Anywho, yeah, you were talking about Google there and how many folks they might have involved and the fact that they're going to be leveraging it for profit. What do you see as
What I would say is it doesn't matter how much money you have and how many people you have. If you're working on a different problem, then you're more likely to solve that different
that
problem.
different problem?
And I mean,
A different problem.
right now, Google is not leveraging their massive resources toward the goal of creating human-level thinking machines. I mean, that's not what their aim is.
That's not their deal.
Their aim is to make more money through search and through ad placement and so forth.
And that's where a lot of their build a brain things are sort of going or whatever there.
Well, Google doesn't have a large AGI team. They certainly could. I mean, they have a lot of money.
I guess they
and a lot
could,
of
yeah.
smart people, but that, in fact, is not what they're doing at the present point in time.
Even with Ray and stuff, it's really about kind of refining their business model of the search and paid click stuff.
Ray was brought in, obviously, in an attempt to stir things up a bit and to see what could be done in a more general intelligence sort of direction. I don't have reason to believe that Ray is controlling a large percentage of their resources at present, and my feeling is that what Ray is doing will focus on natural language processing.
Yep.
Because that's what Google does. I mean, they're not building robots.
No, not right now.
Trying to make AI that will leverage their strengths, which is a massive database of text and a huge number of computers for analyzing that text.
Yep.
And so you have a conceptual question there, which is, are you going to get to AGI by analyzing text and looking at patterns in the massive amount of web pages and searches on those web pages and so forth? Or do you need an embodied system that is more like a human and can go around in the world trying to achieve its goals and integrating visual and auditory and movement data like a child does? Now, if you can get to a human-level thinking machine via text processing or via an approach that is centered on text processing, then I would say Google, Microsoft, IBM have a mighty good chance of getting there because, you know, they are masters of text processing. They have a lot of text, and they have very powerful computers oriented toward processing text. Now, if text processing is not an adequate approach or not a convenient approach to get to AGI, if you really need embodied learning in a somewhat human-like embodiment in order to get toward a human-like intelligence, in that case, that's just not what these companies are doing.
Yeah.
I mean, they could do it, of course. They're making self-driving cars, right? So
Pretty cool.
There's no and God glasses. So there's no reason Google couldn't make human-level robots if they wanted to. However, that's not what they're undertaking at the moment. I think if you really dig into it, there are other issues that make it tricky for a company like Google. I mean, my own view is that building a thinking machine is a highly cross-disciplinary project. I mean, you want to have AI people, you want to have mathematicians, psychologists, philosophers, linguists. You want to have people with many different backgrounds working together. And a company like Google basically consists of a lot of really, really good programmers. Now, of course, that's the core. You need a lot of really good programmers. But I think you also benefit in this kind of project from more of a diverse intellectual background in coming at the problem. And that's possible to do within a company. I don't think that's Google's culture at the moment, just because they're extremely heavily programming focused.
Okay, yeah, cool. So, yeah, working on sort of different problems. I guess a lot of folks are probably pondering, what is Ray doing over there anyway? And I guess it's tough to...
I mean, I to be honest, I pretty much know what Ray is doing over there, but I'm not supposed to tell you. So
You'd have to kill me or something, or send robots to kill me?
Yeah, but
wouldn't want that
we
to happen.
are at the early stages of discussing some collaboration between OpenCog and Ray's team, actually. And one of the leading members of Ray's team is someone who used to work for me in Novamente years ago. So there may be a connection between my team and Ray's a year from now. But I mean, if Ray wants the world to know exactly what he's doing, I guess he will tell you. He doesn't need me to. But I think it's not a direct competitor to what I'm doing, in the sense that he's not making intelligent game characters or robots. I mean, what he's doing is naturally more aligned with Google's core business model. So and there's a possible path to AGI that way, right? Like let's say Google made a question answering system that answered natural language questions about what happened on the web and held a conversation with you about it. You can envision that getting smarter and smarter.
You could.
Until it understood what you were saying. And if that sort of avenue is going to work, they would be the people to do it. I guess the more I have done concrete work toward AGI, the more I have moved into the embodiment camp.
Yeah.
I mean, I started out in the late 90s thinking more like, let's make a human level AGI that just learns everything from the web. And I still don't think that's impossible. But as you get deeper and deeper into actually working on it, you start to see how closely tied human-like general intelligence is with the human body. I mean, not that it's a 100% inevitable connection there, but so much of what we do has evolved for controlling the body and processing data that comes in through the body. If you want to make something with a roughly human-like type of intelligence, that's harder to do if it has no body and no vision and no hearing and no touch. And
yeah.
And if it's not planning and achieving goals in some world with objects and obstacles. Now that's not to say there's not some interesting kind of intelligence that could come out of making a search engine smarter and smarter, though, even if it's not a very human-like kind of intelligence. And then perhaps you can network those two kinds of intelligence together. I mean, the smart Google search engine, which comes to intelligent conclusions of some sort based on all the data there, with a more human-like intelligent robot body, powered by OpenCog with a Hanson robotic space. But these are all connected to the net by Wi-Fi, right? So there's no reason they couldn't synergize together to form some yet different kind of mind that occupies both Google's search database and a host of different robots of different kinds around the world. I mean, then when you get into what other people are working on with brain implants, I mean, the same thing can be what you mentally query for information using your brain implant. So, I mean, I think you could see all these different approaches come together and help accelerate each other. Exactly how long that takes to happen, is that 5 years or 20 years from now, is difficult to say. I'm pretty sure it's not 100 years from now, though. I mean, I tend to buy overall Kurzweilian Vingian timeline that by the middle of this century, humans are not going to be the sharpest pencils in the pack anymore.
Nice. All right, that's more than quotable right there. The sharpest pencils. We will no longer be the sharpest pencils. And on that topic too, just because I know that how long you've been immersed in this field, AI being a major focus for a long time, as you had mentioned, but you've been sort of involved in and more than dabbling in, certainly more than dabbling in, a number of other sort of what we call emerging technology or kind of transhuman, riding that transhuman line kind of technology projects or related projects. And you had mentioned with OpenCog the goal of kind of being that first step beyond humanity in many regards. And that's a big topic that I talk about here on Sentient Potential is with all the various technologies that are in development now, what do you see as sort of the things that you're keeping your eye on in terms of that initial transition beyond human potential, whether it be biotech, gene therapy type things, whether you see it as AI period, a lot of the brain-machine interface stuff is getting a little bit more intense these days. What do you see as kind of the first technologies to potentially cross that line?
Well, I think the key is going to be an increase in intelligence. I mean, there are many fantastic technologies out there. I'm really psyched to see what happens with quantum computing, with nanotechnology. I mean, life extension is of great personal interest because I don't want to be dead. So, I mean, there's a lot of interesting things in development around the world, and the ones that are most likely to make us blast off to the whole new level, these are things that increase the amount of intelligence available. Yep. Because, I mean, one technology, no matter how amazing it is not going to do as much as having smarter beings that can invent an endless series of new technologies.
And that's exactly it, yeah. So what do you see as sort of the...
Well, I mean, you have the familiar spectrum of possibilities. On the one hand, you have AGI and a couple different approaches there. One being a more computer science approach, like I'm taking. One being a more brain emulation approach, which I think will become feasible once neuroscience is a bit more advanced. Then, on the other hand, you have brain-computer interfacing and neural enhancement, like put a chip on your brain, put a USB port in the back of your head to get direct internet access and so forth. Now, my personal guess at the moment is that we're going to get advanced AI first, not necessarily because it's fundamentally easier, but because experimenting with the human brain is slow and painstaking just due to ethical and safety reasons. But it's always easier to see what's possible than to see exactly how long something will take to come to pass.
Yeah.
So, I mean, honestly, none of us can predict how long it will really be until brain-computer interfacing reaches a certain level, or how long it will be until, we can effectively query Google by power of thought, or invoke a calculator or a statistical analysis program just by thinking. I mean, I don't get the feeling that's just around the corner, but there could always be a breakthrough, right? I mean, I do get the feeling that's going to come within our lifetimes. Exactly how soon? Actually, people working in that field would have a better sense than me. I mean, I talk to those people, but I'm not doing that work.
Yep. So, and that's more the brain-machine interface stuff. So you'd say, in terms of kind of the transition beyond human potential as is, the beyond the beyond kind of level of intelligence, you see the initial breakthroughs potentially being a little bit more likely in the world of AGI than in actual brain-machine interface in terms of the enhancement of our potential by plugging stuff in.
That is my guess.
Yep.
But I mean, if I were a billionaire, I would be investing heavily in both of those areas. So I mean, I think those are both things we should be pushing forward with as our life extension, nanotechnology, quantum computing. I mean, all these areas are important and all have the potential to work together. I mean, say an advance in nanotech could give us what we need in order to make brain imaging work better, which would let us build brain-emulating AGIs. An advance in nanotechnology could let us build a better brain-computer interfacing device. So, I mean, I think all these future areas of technology have the potential to synergize together. I mean, just as we've seen in other areas. Look at, say, computers versus machine tools. I mean, better computers let us design better machine tools. Better machine tools let you build better computers, and you always have this kind of synergy by means of which different kinds of technologies help to lever each other up progressively. And I think we will see that same sort of thing with a host of these currently futuristic sounding technologies during the next few decades.
Yeah, that's the whole law of accelerating returns in many respects, is those cycles that you pointed out there. The last couple questions here, one of which is out of my own curiosity and something I explore a lot, is we've interviewed people in more the philosophy domain and also people more in the tech side of stuff, is assuming kind of the relevant increase in human potential, assuming whether it be, let's work on exoskeletons and making people stronger or more physically capable, living forever, massively more intelligent in so many other respects. You had mentioned more creative. As we gain these, as we gain these abilities, how do you see kind of humanity sort of still living and/or working together? Presumably, it almost seems as if our intelligence is increasing, that almost allows for kind of more tinkering with consciousness, potentially more domains or reason for conflict, whether it be direct or indirect. And if we all become infinitely more capable at the same time, it almost seems tough that the world and/or society and/or other people would be able to make it. What are your kind of thoughts on that in terms of how?
Well, I think that's an interesting question, because your intuition, as expressed there, is almost opposite of my line of thinking.
Interesting. Okay, go ahead.
One of the things I've been thinking that would come out of brain-computer interfacing is a kind of internet-mediated telepathy, in essence. If I put a brain chip in the back of my head, you have one in the back of your head, we could beam our thoughts and feelings to each other directly. So if you have human beings with their brains networked together like that, that would seem to enable both a level of empathy and compassion and understanding beyond what we have now, and also the formation of various group minds, where, say, a software development team, all of them sharing their thoughts and their understanding of the code through the day by direct brain-to-brain interfacing as they work. And in the early stages, before AGIs are much smarter than people, perhaps some early-stage AGI programming system networking its brain together with the brains of human programmers as they sit there and type their code. And this sort of interfacing could allow us to become closer to each other and closer to our developing intelligent machines, and in a way going beyond the whole individualistic model of the self that we have now. Now, of course, what I just described is quite speculative, and we don't know what direction either brain-computer interfacing or AGI is going to go in concretely. But certainly within the collection of potentials that loom as we develop these technologies, there are potential realities in which compassion, togetherness, and collaboration increase a lot.
Yeah.
Dramatically, rather than decreasing.
And I think, from my own kind of intuitive perspective, I certainly wouldn't be brash enough to state that my intuition is certainly a negative one, that, as we increase our capacities, we'll conflict.
Well, so far, I think the impact of computing and communication technology has been more social than people predicted. Like a lot of people predicted when you had advanced computers, people would just be sitting there at their computer lost in their own virtual reality and no one would ever talk to each other. There was a lot of science fiction like that. I remember Isaac Asimov had a novel about a robot detective going to a world to solve a crime. And on that world, basically, people never talked to each other. They were all sitting in their fancy houses, interfacing with advanced computers and virtual realities. And in fact, virtual reality has been kind of a dud so far. Second Life isn't that big. Instead, we have mobile phones which let us connect with each other and do video conferencing like we're doing right now.
Yeah.
And the biggest use of computers for most people is Facebook and Twitter and email and mobile phones, which are powerful computers used for SMS. So I would say now, in many ways, we're more connected than we used to be. I mean, but the nature of the connection has changed.
Yep.
But you certainly couldn't make the argument that so far computers have distanced us from each other. They've changed the nature of our relationship, but they're intensely social because that's how people are. So my best guess is that as we get brain-computer interfacing and AGI, people, by their social nature, are going to find ways to make use of that for more and more intensive social networking of various kinds, rather than to let themselves live in isolated bubbles, because that just seems not to be what most people want to do. Now, of course, once you have AGIs that are non-human and massively more intelligent than people,
yeah,
then you have a whole different ballgame. When you're talking about what people will do with technology, it seems like we have a great urge for more togetherness and openness. And really, stuff like Facebook and SMS, what they've caused is the younger generation to be more and more open and share every nasty little of their lives with each other, rather than, go into a little bubble and only interact with your game
computer or whatever. Yeah.
Yeah.
I think sort of one of the things is that's there are certain constituents of human fulfillment and human nature, I suppose, that you and I are talking about at present, being the social element being a pretty significant one. I suppose the tinkering with the potential tinkering with consciousness or tinkering with our very capacities, which is sort of what we're talking on, that may potentially allow for, if we can become, let's say, 100, 1,000 times more intelligent, who's to say we couldn't maybe eliminate negative emotion, let's say, so you talk to guys like David Pierce, or who's to say we couldn't edit which constituents of fulfillment we want to actually affect us, be it, maybe we choose not to have the relatedness thing really matter as much and we want the creativity thing to matter more, or maybe we want to...
That's possible. On the other hand, if you look at human history, the process of trying to transcend the individual mind and improve oneself has also generally been a social pursuit. I mean, religions tend to occur in groups. I mean, you have group meditation sessions,
Yep.
which usually a more reliable way to get beyond your individual self into a profound state than meditating on your own. Because just meditating in a group with others, you get into the trance state more easily. If you look at psychedelics, I mean, most people tend to trip on acid in groups. You can, of course, go in a room and do it by yourself, but if you're meditating or tripping on acid yourself, there's generally more of a chance that you'll kind of go off some weird little corner of a mental direction and not advance. And
Yeah.
people tend to do these things together in a group for a reason. The social element actually helps us overcome the barriers that we place in the way of ourselves and to advance sort of a broader understanding. So again, I would say, as long as it's a human-like mind driving things, seems like the drive to self improve, but to go beyond the individual mind. And generally, people tend to find that's best pursued as a group rather than individually. And I think that is deeply wired into the human mental makeup. I don't think you get beyond that until you're totally beyond the human mind architecture.
Yeah, yeah, I
And
think.
once you're not a human anymore, then almost all bets are off, right? I mean,
Yeah.
then you're in a whole other domain, which none of us understands very well.
And I know Peter Diamandis at the event we were just attending there on Saturday had spoke of sort of his conception of what the ultimate vision might be, or what a more far off future for transhumanism and human potential might be, which would be kind of that uh, ultimate unity of our consciousnesses and our capacities into kind of almost a single entity, which would go out and expand as kind of a united front in many regards. And then they had I forget the name of the Swami who was there, and he spoke more of, at this certain level of development, we'll all be able to create our own universes and expand and create and play in as many different universes as we want. So he seemed to kind of keep some level of individualness. You're speaking a lot of the overcoming of the self, or the going beyond the self. Are you sort of congenial with Diamandis's kind of inevitable concept of our merger, not just with machines, but with each other?
Well, inevitable is
Is a, yeah, pretty strong word.
and we don't really know what's going to happen. I mean, one of the things I've been very impressed with throughout my life is how little we know and how ignorant we are and how bad we are at predicting what really will happen in detail. So it's hard to say with certitude, but
Certainly.
I think that aspect will be there. Yeah, I mean, I certainly individual minds associated with individual bodies, like within their own subjective world, communicating via low bandwidth mechanisms like language. This will not be the only kind of mind in the future, and it very likely will not be the dominant kind of mind in the future, because it's just not efficient, if nothing else. I mean, there are problems with the unhappiness and suffering that's caused by the separation of people and our inability to understand and come together with each other as well as we would like. But beyond that, there's just plain informational inefficiency there. I mean, I learned something. I spent a lot of energy and time learning that thing, and I can't transmit it to you except by taking years and years, right? And
yeah.
That's an informational inefficiency, which is therefore an economic inefficiency, and that is almost sure to be overcome, just for practical reasons, quite apart from the emotional or ethical or aesthetic reasons, which I think are also there. But to what extent individual minds like we have now will still exist is hard to say. I mean, we haven't obsoleted the insects, for example. There are still many insects around, and they have their own part to play, and it might be that human-like minds remain long after this new kind of more distributed, network-oriented, broad-based intelligence also has come into being.
Cool. Yeah. No, it's an interesting way to put it. But I'm definitely congenial with the inefficiency aspect, and how that almost seems like, given where we're going and given that overcoming inefficiency has sort of been a or the massive theme of technology, that some of that stuff's going to have to go. With that being said, and as kind of a wrap-up question, because this is something that fascinates me, you had mentioned kind of having an interdisciplinary approach to your particular project there with OpenCog. As people in this domain, in this field, whether philosophers, intellectual contributors, technology folks, presumably what we're aiming to do is make kind of this transition to transhumanism, this going beyond human potential, a good thing, right? we're hoping that, we're crossing our little fingers that, hey, we're all working together and we're going to create a better world, not just a better world, but a better consciousness, better sentience for all of us in the future. What do you think, based on kind of working in so many of these various areas of interest and collaborating for so long in this field, what do you think are kind of the core aspects that we as contributors to this domain need to be keeping in mind to ensure that this future is as good a one as it can be?
Well, I think the main point we need to keep in mind moving forward is our own ignorance about what the future is going to bring, and the need to be open-minded to the various possibilities that might unfold. I think we all have a tendency to become attached to our specific ideas of what's going to happen, and be that the idea of life extension in the human body, the idea that we'll upload ourselves into robots, the idea that it's going to be a robot or a game character in a body that's intelligent rather than something new. I mean, each of us has research directions that we're pursuing now, and of course it's important at any point in time to pick the direction you think is best and push on with it. But the characteristic of the singularity that makes it the singularity is that things are changing faster and faster, that revolutionary new ideas are coming up faster and faster, and by the same token, old ideas are going to be obsoleted faster and faster. So I think it's a challenge for us as human beings to change and adapt fast enough in our own minds, since we are the ones pushing this forward. The demand on us to change our minds and advance our own understanding more and more rapidly is going to be more dramatic than ever before. There's a saying that science advances one funeral at a time, meaning old scientists never change their minds. They just eventually retire, and the new generation comes along and with a new idea, right? And that's not going to work anymore when science is advancing so rapidly compared to the human lifespan. It means that scientists and technologists and business people actually have to change their minds multiple times during their career, maybe even multiple times each year. And that's an adaptation to both our individual way of thinking and managing ourselves and our egos, and a challenge to our social institutions, which often have a lot of inertia built into them. For example, on the social level, I mean, right now, within academia, it's easier to get a research grant for a variation on something you did before. And if you've gotten research grants in one little area before, it's hard to convince them to give you a grant for something new that you thought of, which is totally different. So this kind of institution has inertia built into it. But as the singularity approaches, and change gets faster and faster and more profound, institutions, just like our own individual minds, will have to adapt and revise themselves faster and faster. So I'd say, rather than any new idea we need to embrace or get used to, we need to get used to the process of changing and adapting all the time, and not just on the surface level, but ultimately on the most profound level of our understanding of who we are, what we are, and why we are. And some of our thinking about the singularity itself is bound to evolve dramatically as the singularity gets close. I mean, ideas like friendly AI or life extension are not necessarily that well defined. I mean, what is friendly to humanity? What is humanity? Talk about life extension. What do you mean? Prolonging this exact human body? Prolonging our mind in a related body? What is our mind? What is me? Am I the same as I was 45 years ago? Am I the same as I was last night before I went to sleep? Am I the same as I'll be once I pack a bunch of chips in my head? I mean, our way of thinking about these things is going to evolve as well. So we'll have to do some fancy inner footwork in order to keep up with all the changes we're bringing about.
And with that being, I agree in that regard. I think that the pace will be just faster than it's ever been, and then a lot of those philosophical concerns I don't necessarily see being solved, like like simple math problems per se. But I think that does make things interesting, and I don't think it means we can't move um, beyond them. Do you think it's important for us to, as we keep our minds open to, because different people are bound to have different ideas, as we transition forward, to kind of carry that virtue of empathy sort of in mind as we move forward, as different people have different ideas of what the future needs to be, or working on different projects, or see the self as meaning different things? Um, how do you see us potentially overcoming kind of some of those philosophical hurdles, or approach hurdles, or maybe some people that do kind of keep their heads in one track, like you had explained with scientists? Is it about sort of collaborating with each other and getting to know each other a little bit better, or how do you think we can overcome
I think
that
the
aspect?
very nature of philosophy is likely to change, and that's already happened in history. I mean, philosophy and science were kind of the same thing.
Even in Newton's
A
day.
couple 100 years ago, right?
Yep.
And you had natural.
Philosophy.
The founders of science were natural
Philosophers,
philosophers, and
yes.
they would write about the mind and consciousness and the cosmogonic origin of the universe at the same time as they were writing about chemistry experiments they were doing. And now, in the 20th century, these things diverged significantly. You had the emergence of experimental science as a separate discipline, becoming very industrialized, really, and connected with engineering, which has been beneficial.
Yep.
And philosophy became very, very technical and academic, rather than being about individual thinkers, like sitting in their study, trying to understand the whole universe.
Yeah.
Some guy trying to solve a very, very narrow philosophy problem that's almost as narrow as a math proof in some little corner of mathematics. And I think that's going to change. I think you're going to see a reconvergence of science and philosophy in a way, because we're going to be able to do more and more experiments related to things like consciousness and the nature of reality. I mean, when you can put a chip in your brain or fuse two brains together in some way and see how it impacts the conscious experience of those minds, you know, you're meshing together the philosophical, introspective aspect with the scientific, empirical, experimental, engineering aspect in a way that's not happening now. So we may not solve once and for all these big philosophy problems, but we may get into a different rhythm of inquiry in which incremental understanding on these philosophy problems advances alongside and all mixed up with incremental advances on the science and engineering side. So that is my guess of what will happen.
And the people working on these far corners of different, whether it be OpenCog and other various projects related to the creation of technologies, as you had mentioned, so interdisciplinary, but people working on these emerging technologies that have this potential to move us beyond human potential. Do you believe that on the aggregate, collaborating, working together, and knowing what the rest of the world is working on in this particular space is generally a good thing? I know some people are concerned, what if, if we're not connected, we're not going to learn as fast, and then at the same time, if we're not connected, then someone could be working on something that maybe isn't so good, and we should tell them to stop. Do you see on the aggregate that connectedness being a positive thing for our transition forward?
Well, I mean, without it, I don't think we would make the transition forward. I think on an individual level, it has pluses and minuses. I mean, of course, it's amazing the way we're connected now.
Yeah, it's pretty cool.
I mean, you can talk to researchers all around the world. When someone writes a paper, they can upload the paper and the software code, a video of how they did their experiment. And, of course, in a way, science advances much faster because of that. Now, I'd say there was a very different feeling in the 1980s when I started doing research work, where you could, you'd sit there for a year in your study and think about some problem in a pioneering way, and you were really like a lone wolf there on your own, exploring some weird corner of the intellectual universe, and there was no opportunity to share your ideas with like-minded people, because if you're working on something weird, there were no like-minded people around.
Yeah.
Now, that gave you a feeling of loneliness, but it also let you make some kind of profound breakthrough on your own without polluting the purity of your thoughts with all this interaction with the consensus of other people.
Yeah.
There was something beautiful in that, which we have lost. On the other hand, losing that seems to be part of the process of getting toward the singularity, because, you know, something like AGI or life extension pharmacology, it's not ever going to be built by one guy sitting in his study thinking in his own direction.
Yeah.
They're big and complicated and messy, and necessarily need to be done by large teams of people.
Cool. Awesome stuff. Ben, I more than appreciate you taking the time to get in the interview today. We went off on a lot of tangents, which I'm always happy to do, and I've got a lot of awesome stuff to write on now. So thanks a ton. I'll be looking forward to seeing the progress on OpenCog too, brother.
All right. Sounds good.
Awesome.
Bye-bye.